Well, this is day 4. We've learned to add and subtract matrices. We've learned to multiply matrices. But now we're going to learn something entirely new dealing with matrices. We're going to talk about finding the determinant of a matrix and finding the inverse. And we're going to start with the simple 2 by 2 matrix. So, consider the matrix ABCD. The determinant of this matrix, we would write it this way. If we put this little DETA, that would mean the determinant of matrix A. You know, let's say this is matrix A, by the way. Also, these vertical lines, instead of brackets, would also mean determinant. So even if we didn't say determinant, if you saw a matrix inside of these things that sort of look like big absolute value, it would still automatically mean determinant. It's understood. Alright, anyway, how do you find this determinant? Well, you would do A times D minus B times C. I like to think of it in terms of diagonals. It is basically the down diagonal, there's your AD, minus the up diagonal. That's your BC. So it's down diagonal minus up diagonal. That's how you do the determinant. So, for example, let's look at number 1. If I want to find the determinant of this matrix, which I could either write this way or I could have just put it inside of these vertical lines, I'm saying that it's going to be the down diagonal minus the up diagonal. Okay, so that would be 2 times 7, alright, the down diagonal, minus 5 times negative 3, alright, the up diagonal. So obviously that would be 14. Okay, 14 minus negative 15. And you know that minus and negative is addition. So this is going to be 29. Okay, and that is how you find the determinant of a matrix. Let's do it again. So look at number 2. It's going to be the down diagonal minus the up diagonal. Okay, so the yellow minus the blue, the down diagonal minus the up diagonal. So that would be negative 1 times 6 minus 4 times 3. Okay, down diagonal minus up diagonal. So that's going to be negative 6 minus 12, which is negative 18. Alright, you might be wondering, why are we doing this little puzzle? What's the point of it? What is it used for? When will I ever use this in life? And the answer to those questions will not be answered in this lesson. But please understand that this is going to wind up being the first step in a more complicated process that can be used for things like making and breaking codes, secret messages, and lots of other things. So stay tuned for the uses of this. But you've got to learn to walk before you can run, and we're just walking right now. So down diagonal minus the up diagonal. Okay, so that would be 3 times 1 minus negative 2 times 9. So that's 3 minus negative 18. Of course, that means 3 plus 18. So that's 21. Okay. Looking at number 4, let's just keep practicing a few more. Alright, once again, finding the determinant. is as simple as doing the down diagonal minus the up diagonal. Okay, I'm really hoping that if you're watching this video because you weren't sure what to do, don't just watch me do all of them. Once you get the idea, pause the video and do a couple on your own, and then just play the video to check your answers. But just sitting there watching me do it is not the way to learn. So down diagonal minus up diagonal. Okay, so that would be 3 minus 0. 0 times anything is 0. So that would be 3. One more of these. One more time. Down diagonal minus up diagonal. So that's 2 times 3. Down diagonal minus up diagonal. So that's 6 minus -1. Of course, that is 7 minus a negative is addition relay. Okay, so that's some good practice on how to find the determinant. Now, so baby steps. Let's take one step forward. This leads us to be able to do something called the inverse. We should be able to find the inverse of a matrix. Now, notice that the determinant is involved in that. Now, consider the same matrix we've been dealing with, A, B, C, D. The inverse of the matrix, we use this notation. So this looks like A to the -1 power, but in this context, this is not really an exponent. It means the inverse. And here's the formula for finding the inverse of a 2x2 matrix. First of all, you're going to need the determinant, because right in the front you put 1 over the determinant. Please understand that putting 1 over something is just a reciprocal. Obviously, if I have a number like 3, putting 1 over it makes it 1/3. Guess what? The reciprocal of 3 is 1/3. But what if I had something like 3/4? Okay? Do you know what I mean when I say reciprocal? Reciprocal is that thing where you turn a fraction upside down. So the reciprocal of the reciprocal of 3/4 would be 4/3. Alright, so what I'm saying to you is, if you take something and you put a 1 over it, like this, has the effect of making the reciprocal. Here, look at the calculator. Okay. I thought I told you to clear. Okay. If I do 1 over, now down here I'm going to do 3/4. Okay. If I do 1 over 3/4, I get 4/3. Okay. So putting 1 over something causes it to be the reciprocal. Alright, so in a way you could think of this as the reciprocal of the determinant goes in the front. Now, after that, let's see what's happening. You see the C and the B along the up diagonal here? The C and the B stay where they are, but they are negated. Alright, they're the opposite of what they were. So if C were +3, now it'll be -3. Alright, if C were -3, now it would be +3. Alright, so the up diagonal just goes, becomes the opposite of whatever it was. Now the down diagonal, okay, the A and the D become the D and the A. Alright, so the down diagonal gets reversed, while the up diagonal gets negated. Alright, the opposite. Alright, and you just have to memorize that. I don't really have a nice clever trick like I like to do. Just memorize that the the down diagonal you reverse, and the up diagonal you negate. If anyone can think up a little trick to help us remember that, a song or a rhyme or a reason, please share, and I'll share with the class, and you'll be famous in my classes. Okay, anyway, so if I want to find the inverse of matrix A, which is my ultimate goal, first we need the determinant. So we're going to do just like we were doing before. Okay, we're going to do the down diagonal minus the up diagonal. Okay, so that's what we do first. Find the determinant. So down diagonal minus the up diagonal, and that's going to be like this. So it's like 1 times 4 minus 3 times 2. Alright, so that's going to be 4 minus 6. So that is -2. Alright, so this is the determinant right here. Now, if I want to find the inverse of a matrix, the first thing I do is I need the reciprocal of the determinant. So instead of -2, I'm going to have -1/2. Alright, I did the reciprocal. And then I have to do that little pattern that we were practicing, where the down diagonal is reversed. So 1 and 4 on the down diagonal will become 4 and 1. Now the up diagonal is negated. Alright, they're not reversed or anything, but because this is 3, I'm going to have -3, and because this is 2, I'm going to have -2. Okay, we're just doing the formula. Alright, but we're not going to leave it like this. Remember, when you're multiplying by a number in the front, you take that number and you multiply it by everything inside. Okay, and so we're going to go ahead and make, let me change to red because this will be like the final answer. Okay, we're going to go ahead and build this matrix, but we're doing -1/2 times 4. Okay, so that would be -2. Alright, I mean, I'm doing that in my head, but -1/2 times 4, okay, that's like 4 over 1. You know, that's like a negative. 1 times 4 is 4. 2 times 1 is 2. 4 over 2 is 2. Okay, that's where I'm getting -2 from. Alright, I'm hoping you can do it in your head. Like half of 4 is 2, so that's where the 2 is coming from. Now, if I do -1/2 times -2, first of all, a negative times negative is positive, so I know this will be positive. Now, what is half of 2? Half of 2 is 1, so that'll be a positive 1. Alright, again, a negative times negative is a positive. So 1/2 times 3, well, that's just going to be 3 over 2. Positive 3 over 2. Alright, now again, I'm very comfortable doing that in my head, but if you're not comfortable doing it in your head, either use a calculator or do it off to the side. So I just did -1/2 times -3. We know it's going to be positive, so let's just focus on the 1/2 times 3 aspect of it. Alright, I put it up high because I'm going to think of it as 3 over 1. 1 times 3 is 3, 2 times 1 is 2. That's where the 3 over 2 is coming from. Alright, anything times 1 is itself, so this is just going to be -1/2. So this red right here, this would be the final answer. This would be the inverse. Alright, now, if you're watching this video because you needed help on number 6, now you've seen me do one. Pause the video and try to do number 7 on your own. Do not just watch me do 2 in a row. Try to do number 7 on your own right now, and then you can play the video and see how you did. I'll wait. Okay, now you started the video again. Alright, I'm obviously not there. I don't know what you really did. But if you know what's good for you, you did this problem on your own. The first thing I need to do is do the determinant as we discussed a moment ago, where I do the down diagonal minus the up diagonal. Okay? Now, as you get more and more clever, you're going to skip a couple of steps. And so here's some things that are okay. Down diagonal, obviously that's 3 times 3. You can just go ahead and put 9. You don't have to do 3 times 3 like I've been doing. So you can go ahead and say 9 minus 10. Alright, down diagonal minus up diagonal. But please show this. Alright, do not just go straight to -1. Alright, so fine. This is the determinant. Now, to do the inverse, the first thing I do is I do the reciprocal of this. Well, the reciprocal of 1 is still 1. So guess what? As far as like the reciprocal, it stays -1. 1 is the reciprocal of itself. So I'm going to leave that there. Now I'm going to do the little deal. Alright, using this pattern. The down diagonal is reversed, the up diagonal is negated. Alright, so the down diagonal is reversed. Well, guess what? That's not going to really appear to change, is it? Reversing 3 and 3, it's still 3 and 3. But the up diagonal is negated, so this will be -2 and -5. Okay, the final step is to take this multiplier, you know, that reciprocal of the determinant, and multiply everything by it inside there. I'm going to switch to red because this is the final answer. So the final answer here would be -3, +5, +2, and -3. Alright, just multiplied everything by -1. So that is how you find the inverse of a 2 by 2 matrix. Oh look, it looks like we have one more. Again, pause the video. If you have not done number 8 yourself, pause the video and do number 8 right now. Go ahead. Okay, hopefully you did the right thing. Little cheaters. Okay, our ultimate goal is to find the inverse, but first we have to find the determinant. One more time. The determinant is the down diagonal minus the up diagonal. Okay, so that's going to be 2 times 3, so that's going to be 6, minus 1 times 4, which is 4, which is equal to 2. Okay, so that's the determinant. In order to find the inverse, you start by doing the reciprocal of this. So the reciprocal of 2 is 1/2. Just turn it upside down. 2 over 1 becomes 1 over 2. Now, inside of here, I do the little pattern that we memorized. The down diagonal gets reversed, so this will be 3 and 2. The up diagonal gets negated, so this is -1 and -4. Now I'm going to take this 1/2 and multiply it by everything, and that should be the final answer. So half of 3 is just 3 over 2. Half of -4 is -2. Half of -1 is -1/2, and half of 2 is 1. Okay, if you had any trouble with any of those multiplications, you know, you could always use a calculator. Am I right? For example, if you needed to, I mean, I'm hoping you don't need to, but if you do, you can always do half of 3 and see that that gives you 3 over 2, or half, I hope nobody needs this, but half of 2 is 1. Okay, so if you need it, there you go. Anyway, that's the answer for number 8. Let's move on. Given D and B, find the product of D times B. Alright, so this is like a little review concept. Alright, so we're not doing the determinant, we're not doing the inverse. This is what we used to do. Okay, so let's not forget how we used to do it. It used to be like this, guys. Alright, seems like only yesterday, or should I say 10 minutes ago for some of you. Remember this, okay, yeah, the analysis. This is a 2 by 2 matrix, and this is also a 2 by 2 matrix. Is this even possible to multiply? Well, yes it is. I'm glad you asked that. It's a very good question. It is possible because the inner dimensions are the same. Okay, fine, it's possible. What will be the shape of the product, the answer? That always comes from the outer dimensions. Alright, so my answer is going to be a 2 by 2 matrix. That's why I am setting up a 2 by 2 matrix right now. And I'm going to call this element 1, 1. I'm going to call this element 1, 2. Now, this stands for row 1, column 1, where this sits. This is row 1, column 2, where this is. This is row 2, column 1. So, thus, element 2, 1. And this is element 2, 2, because this position is in row 2, column 2. So then I set about finding each one of these things one at a time. Okay, so say if I want to find element 1, 1. That means I need to do row 1 times column 1. Okay, so row 1 is 2, 1. Column 1 is 4, 6. Alright, so fine, that's 8 and 6. Alright, and that is 14. Alright, so element 1, 1 is 14. Okay, let's keep going. Let's find element 1, 2. Element 1, 2 means we need to do row 1, column 2. Row 1, column 2. So there's row 1 is 2, 1. Column 2 is 7, 0. So that is 14 and 0, which is 14. Okay, so that means this is going to be 14. Whoa, 2 14s. What a coincidence. Now let's move on to finding element 2, 1. That means I need row 2 and column 1. Row 2 is 5, 3. Column 1 is 4, 6. Alright, so that is going to be 20 and 18. So that's 38. Okay, so that means this element right here is indeed 38. Alright, last one. I'm going to find element 2, 2. That means I need row 2 and column 2. Row 2 is 5, 3. Column 2 is 7, 0. So that's going to be 35 and 0, which is 35. Alright, so that last element there is, in fact, 35. Alright, so there it is. I feel like this should be red because I've tried to put my answers in red. Oh, 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 it's magic, you know. Alright, so that's the answer over there. The product of a matrix. So that was a little review because we're going to need that for this last problem. Okay, this is the last little detail I want you to learn from this lesson. The product of a matrix and its inverse is the identity matrix. Alright, this is like a little rule. Alright, let me read that again. The product of a matrix and its inverse is the identity matrix. Okay, now this is the identity matrix. We call it I for identity. And what it is the down diagonal should be all ones, and there should be zeros everywhere else. And by the way, that'll happen with bigger matrices too. It's not just 2 by 2 matrix that have an identity matrix. Say if I have a 3 by 3 matrix, for example, a 3 by 3 matrix would be 1, 1, 1 down the diagonal, and we'd have zeros everywhere else. This would also be the identity matrix. Okay, we'll talk more about that in future lessons. But for now, understand this. If you have an inverse and the original matrix, if you multiply them together, you should get the identity matrix. So, given these two matrices, if I want to determine whether they're inverses, one way that I could do it is, pardon my yawn, but it's like 20 minutes to midnight, and so thus the yawn. One way I could do it is multiply them together and see if I get the identity matrix. If I do, I know that they are inverses of each other. So let's check that out. So let's multiply these together just like we just practiced, just like we did for number 9. Here again, if you're watching me do this, now would be a good time for you to pause the video. I've already given you the hint that you're supposed to multiply these together. I've already showed you and reminded you how to do it for number 9. So pause the video, please, and try to do number 10 by yourself. And then you can play the video, see how you did. Okay, based on the fact that these are both 2 by 2 matrices, and we already discussed how it all works, you know that the dimensions of your answer should be a 2 by 2 matrix, because it's just like number 9. So let's set that up. Alright, so once again, the dimensions of this of the answer should be 2 by 2, and this will be element 1 1, element 1 2, element 2 1, and element 2 2. Okay, and we just hunt these 4 guys down one at a time. So let's do element 1 1, row 1, column 1. Row 1 is 3 and negative 4, and column 1 is negative 5, negative 4. And that is going to be negative 15 and positive 16. Oh, look, what do we have here? We have a 1, governor. So let's see. Let's just erase that. So this is going to be a 1. So far, it's potential still for the identity matrix. Okay, if these are inverses and this is going to be the identity matrix, this next one should be 0. Let's see if it is. So we are doing element 1 2. That means row 1 and column 2. Row 1 is 3 negative 4, so 3 negative 4. Column 2 is 4 3. Okay, so that's giving us 12 and negative 12. Oh, would you look at that? 0. So far, still looking good for the identity matrix. Okay, 1, 0. Alright, let's see if the next one turns out to be 0, like it would have to be were it the identity matrix. So I am doing element 2, 1, which means I'm going to do row 2, column 1. Row 2 is 4, negative 5. Column 1 is negative 5, negative 4. This gives me negative 20, positive 20, which is in fact 0. Alright, really looking like it's going to be the identity matrix. So one more. Let's see if this turns out to be a 1, which would make this the identity matrix. So let's do element 2, 2. Alright, that means we're going to do row 2 times column 2. Row 2 is 4, negative 5. Column 2 is 4, 3. But this is going to give us 16 and negative 15, which in fact is 1. Okay, which means this is going to be 1. So we see this is in fact the identity matrix, and like we saw, the product of a matrix and its inverse will always be the identity matrix. So we're going to go ahead and conclude that, yep, they are inverses. Alright, now technically, to really prove that they're inverses, I should multiply them both ways. So I'm supposed to prove it, I need to do P times Q and see if that equals the identity matrix. Alright, we just saw that. But I should also do Q times P. Okay, and that should also give me the identity matrix. But I'm just going to do you a favor and just tell you, yes, if you were to do it the other way, you would get the identity matrix again. So you're welcome. I just saved you 5 minutes. Alright, and that is the end of this lesson. I taught you a lot, and I'm not even really there. I'm like a ghost in your mind. Ha! We're in the matrix. Anyway, I will see you on the next video.